everyone, welcome back to the Foamy Fizzy Fluids in Houdini tutorial. In our last video, we surfaced our liquid points, and we created an additional fizz element that emitted from that liquid surface. In this video, we'll create our final two additional elements for our simulation. The two elements I want to make are two different bubble elements. One that's going to be driven by our main simulation, kind of swirl around and rise up inside of our liquid, and a second set of bubbles that are just static and kind of stuck to the inside of our glass. We're going to source both of these elements from our glass geometry, so I'm just going to go in our network to our glass object and throw down a null just for easier access. Just plug that in. Change this to glass. I just like to make nulls purple, as you might have noticed. And I'll just bring it down to our workspace down here. So now we have our glass object. And I'm also going to subdivide it to give us a few more polygons to work with. Let's set that to 2 so we have a nice amount of polygons. Now for the bubble emission, I want the bubbles to emit from the inside of our glass along the bottom. So I'm going to isolate those faces. So I'll just pan around, zoom in down here, switch to selection mode, and switch to lasso mode, and I'm also going to check only visible polygons, so that way I'm not selecting polygons that are somewhere beneath this area. I'm just going to grab this first little circle here, hit Shift G a couple of times to expand our selection, and I'm going to switch to wireframe and then switch back to our camera so I can see how far up I've selected. Hit Shift D a few more times until we have a nice little pool of faces along the bottom. I don't want any that are too far up because I don't need bubbles to emit basically from the sides of the glass. So this selection's probably fine. So I'll just hit the delete key. And then on the blast node that's created, I'm just going to switch this to delete non-selected. So now we just have those faces that we isolated. And then after we've isolated this geometry, I'm going to put down a scatter. And these are going to be the points that our bubbles are emitting from. And we can reduce the overall amount of points quite a bit. So I'm going to set that to 50. And one thing to keep in mind is if you scrub through the timeline, you'll see that all of the points are the same on every frame. So if we leave it as is, the bubbles will emit from these points in the same position on every frame. And that'll create a pretty uniform emission and won't look very interesting. So to add some variation to the position of our points on each frame, I'm just going to change our global seed to $T. That way it's reliant on the current time. So now if we scrub through, you can see that the position of our scattered points changes on each frame. I'm also going to turn down our relax iterations. If we pan into our points and take a closer look at them, you can see that they're pretty uniformly spaced from one another, which will create a much less organic result. So to reduce this uniformity, I'm going to turn down the relax iterations in our scatter node. You can just turn it down a bit. I don't want to turn it down too much where they're intersecting with one another. So we'll just turn it down to say 1. That way we have some variety in their position. Then with these source points created, much like we did with our fizz, we can just create a pop sim. So create a pop network. And just plug that into the first input. And I'm going to call this Rising Bubbles Sim. And then we can go back to our first frame and hop on in. The same deal as when we set up our fizz simulation, we can get rid of this merge node, we don't need it. And like the fizz, we'll have to change our emission type to all points. So now we have the points that we've created. And if we scrub through our timeline, you can see that the points are just generating and not moving. They're just overlapping on one another and building up. And that's because we don't have any velocity on our source points like we did with our fizz. So I'm just going to add a pop force. Pop force. And give them some upwards Y motion as well as a little bit of motion in the X axis. So let's do 0.03 and 0.22. So now if we scrub through our timeline, you can see that we're getting emitted points and they're rising upwards. So now we have a force on our points. Now one thing we'll need to change is how our points are emitting from this initial cup area from the very start of our simulation. Obviously, we wouldn't expect to have these bubbles emitting when there's not even liquid in the cup yet. So we want to make sure that our source points are only showing up in areas where the fluid is currently active. So we can go back up above our pop sim, and we'll isolate those points. So to do that, I'm going to put down a group node, plug it in beneath our points, and I'm going to name the group active. Switch the type to points. I'm going to disable base group, and we're going to enable keep in bounding regions. We're going to set it to an object. The object we're going to use is the surface fluid that we created. So down here we can go to where we've cached out that surface. So now if we display this group, you can see that it's grabbing our liquid object and it's using it as a guide for the grouping of the points, but you can see it doesn't seem to be picking up some points that you would expect it to be grabbing. The reason for this is that the points are basically completely flush, intersecting with the glass object as they're scattered onto it. So the liquid isn't entirely overlapping them and adding them to the group. And we can fix this by simply expanding our fluid slightly so that it grabs our points. So we can just put down peak node, and we'll put it in our connection for our bounding object. And then again, this is a pretty delicate slider, so we want to use a pretty small value. Say something like 0.001. So now you can see we've expanded our fluid ever so slightly. If we go back to our group node, you can see we've grabbed those points. So now you can see it's only activated these points once the fluid has touched them, so that way the bubbles won't emit in areas where the fluid's not touching. And to make sure that those points only show up there, we'll just put down a delete. And we'll set it to our group active points, and we want to delete non-selected. So that way only our active points show up. And as I mentioned before, since we're scattering our points on the surface of our glass, they're basically intersecting with our glass. And that's going to be a bit of an issue once we bring in our glass object as a collision object. So we're going to want to peak our points as well. So we need to scroll back up to where we are scattering our points, and we need to add some normals to our geometry. So I'll just plug in some normals. Then we can just put down another peak node. Again, using a very small value. So now if we display that, you can see that we've moved them ever so slightly off of the glass surface, that way they're not intersecting with the glass. Speaking of using the glass as a collision object, we can go ahead and grab that collision object from either our main sim or our fizz simulation. We can go ahead, go into our fizz simulation, grab our static object, copy it, and then hop back into our bubble sim. And paste it, doing the same thing we did when we were setting up our fizz simulation. Connect it in on the left side, connect our solver, and there we go. Now we have our glass and our simulation. So now if we scrub through, you can see that our points did not start emitting on the very first frame. And if we continue to scrub, you can see that they are interacting with our glass as you would expect. Now if we keep scrubbing, you'll see that our points are continuing to emit basically forever. They're going to keep emitting upwards. Now you might remember in our fizz simulation, we changed the life value of our particles so that they would die off pretty quickly. And we could do that here, but rather than focus on the life attribute, I want to focus on the position of the particles. I want to make sure that the points for our bubbles aren't going over the top of our glass. So rather than changing the life attribute, I'm going to put down a pop kill. This basically lets you set up a specific rule to kill particles when certain conditions are met. Now we could just go over to the bounding tab and set a bounding box, but since I already know the general position and Y at the top of our glass from previous wrangles, I'm going to go ahead and do it in a vex expression. So I'm going to enable the rule, and I'm going to put an if statement. So if the position at Y is greater than 0.19, then dead equals 1. So now if we go back to our first frame and scrub through again, you can see that all of the particles are dying off around here in our glass. And while this does create a harsh line across this position in Y, that's actually fine for our purposes because the bubbles are ultimately going to be clipped by our liquid mesh. Having this rule just prevents unnecessary points from existing in our scene. In addition to making sure that our bubbles are only emitting where the liquid is currently touching, I also want to make sure that our bubbles aren't emitting at a constant rate. At the beginning, having this large amount of bubbles is fine, but you would expect the bubbles to kind of reduce in their overall emission rate as time went on. So we can go ahead and go up and change that in our scatter node. So just go to our scatter, and we can just keyframe our total count. Just Alt left click to set a keyframe, and then I'm just going to scrub to the end and set it to 0 so that by the end it's not emitting any new bubbles. So now if we scrub through, you can see the amount of points is reducing over time. Now that we've sorted out our sourcing and our collision, we can focus on the motion of our bubbles. Obviously, you can see that we're getting a pretty uniform upwards motion since we're just using a single pop force pushing them all at the same rate upwards in Y. And we can break that up using the same pop force node by increasing the amplitude of the noise on the force. So let's increase it just a little bit, say 0.25, so that's not too strong. If you scrub through, you'll see that we're getting a pretty drastic shape. That's because our swirl size is pretty big for the small scale scene we're working with. So we're going to turn this down to a pretty small value, say 0.06. So now if we scrub through, now you can see we're getting a nice little back and forth motion, a little bit of turbulence, just giving it a little bit more of an organic feel. So let's go ahead and play blast this to see how it looks when it's playing back at frame rate. So now you can see we're getting some nice turbulent motion. The bubbles are moving a little bit fast, and we're also missing that turbulent motion that we get with the liquid, where the liquid's pouring down in and creating a lot of movement down here at the bottom. So I'm going to add some drag to our particles, as well as bring in the velocity from our main simulation to drive some of our bubble motion. So I'm just going to go ahead and put down a pop drag, plug that in. And then I'm going to go back above our simulation, and we're going to grab the velocity from our main simulation. So if we go back over to where we have our liquid points, I'm going to put down a volume rasterize attributes. And what this will do is it'll create a volume based on a specified attribute. So we can go ahead and plug that in, bring it back over here to our work area. And then the attribute I want to grab is the velocity, so we'll just change this to V. And if we display this, we can't see anything, and that's because you can't really see velocity volumes in the viewport at default. So to get a look at what we're working with, I'm going to put down a volume trail. So this will take our velocity volume as well as points, so we'll plug that into our liquid points. So now you can see that we're picking up something. And this doesn't really match what you might expect to be seeing from our fluid simulation, and that's because we're not getting a very refined result. Our voxel size is too large, so we need to reduce it. And again, we're working on a pretty small scale, so I'm going to reduce it quite a bit. And it'll take a bit for that to cook, because the more we reduce this, the higher resolution the volume trail is, and that is what's taking the most time for it to cook in our viewport right now. But now that we've reduced our voxel size, you can see we're getting that swirly motion. You can see all the variance in velocity in our simulation that you would expect. So we're going to take that rasterized volume, and I'm just going to plug it into the second input of our simulation. And we'll hop back into our dot network. And then I'm going to put down an advect by volume, pop advect by volume. And we can go ahead and plug that in. And it's our second input is our source. And then we have a field name. And if we go back up and we middle mouse, you can see that our field is just called V. So we'll just change the field name from vel to V. And then just to make sure that this is working as expected, I'm going to bypass our other force nodes that we're just seeing the advection. So now if we scrub through our timeline, you can see that we're getting definitely some velocity. It's pushing the particles out to the side with that first initial pour that comes down. So now that we know it's working, we can go ahead and turn back on our pop force so we can see the two of them interacting together. So let's scrub through our timeline. You can see we're getting that initial push, but it might be a bit too strong. We have a little too many bubbles pushing up against the side of our glass. So we can just reduce the scale of our incoming velocity volume. I still want it to affect our bubbles, but I don't want it to overpower our simulation. So I'm just going to change it to about half. Then we can go ahead and play blast this to see how our motion is looking. So now you can see we've got a nice overall motion. We're having our bubbles emit where the fluid's hitting. They're being pushed around by the velocity of our fluids while continuing to rise up to the top. And it's a nice organic feeling. And I'm pretty happy with our simulation as it is now, so we're going to go ahead and start cashing out our points. Let's go back up above our simulation. And then just like we did with our fizz, we're going to change the object to pop. That way we're grabbing our pop object and not the static object when we are importing the geometry. Then I'll just copy one of our other cache nodes, plug it in, and I'll just call it Bubbles Sim Video 1. And then go ahead and cache it out. Now with our points cached out, we can go ahead and start turning them into geometry. It's going to be a pretty similar process to what we did with our foam bubbles. To start off, if we middle mouse, you'll see that once again we don't have a p-scale because this was a simple pop network and not a flip simulation. So to create a p-scale, we can just go ahead and grab the random p-scale that we used on our fizz simulation. We can make a copy of that. Just plug that in. Then scrub somewhere we have points, and we'll put down a VDB from particles node. Same deal as before, we're going to need to reduce these values, so reduce our minimum radius and our voxel size. Say 2. And then also switch back to shaded view so that we can actually see our voxels. And you can see that these are pretty small, and that's because we copied our p-scale from our fizz, and our fizz is pretty small. So we can go ahead and increase this value as needed. So it'll be a bit bigger. Let's change this to 2. So now you can see we've got some sizes that are a little closer to what you would expect for bubbles. Now, even though I reduced our overall scattered points, and we only had 50 points emitting on each frame, this still seems like a lot of bubbles overall. So I'm actually going to go over to our large foam bubbles, where we were working with those before, and I'm going to copy this wrangle we created that reduced the overall amount of incoming points. So I'll just make a copy of that, bring it over, and just plug it in down here. And this will just let me reduce the overall amount of bubbles that are coming into our VDB from particles. I could just go back to the top of our simulation and reduce the number of scattered points, or I can just reduce the amount after our cache. It doesn't really matter in this specific situation since it wasn't too heavy of a simulation, but I'm going to go ahead and just reduce them here. So I don't need to reduce them quite as much as I have for the large foam bubbles, so I'll turn this value up some. So now you can see we still have a nice amount of bubbles rising up inside of our glass. So if we bypass this, you can see just how many we're getting rid of. And then again, we have a seed value if we want to change up the bubbles that we're getting rid of. And as I mentioned earlier, when we were setting up our simulation, we have this harsh line up at the top where all the bubbles are dying off, basically hitting that maximum Y value. In addition to that, if we scroll earlier in our timeline and we take a look at our liquid surface, you can see that we have bubbles that are moving upwards and moving outside of our liquid, which is definitely not what we want. So to fix that, we're going to clip our bubbles by our fluid. And we're going to do that using a VDB combine. So we'll plug in our bubbles to the left input. And then in our right input, we're going to use our liquid. And specifically, we want to use a VDB of our liquid. So what I'm going to do is go up here to our points where we surfaced them, and I'm going to make a copy of this surface node. And drag it over here. And then on the surface node, on our output, I'm going to change the output from surface polygons to surface VDB. So now if we display this, you can see that we have the VDB of our fluid object. So we can go ahead and plug that in down here to our VDB combine. And then on the VDB combine, I want to change the operation to SDF intersection. So now if we display that, and we zoom in, you can see that the bubbles are being clipped basically by this incoming VDB. You can see that once they reach the top, they're getting clipped by the surface of our fluid. Then we can go ahead and convert our VDB bubbles into polygons. So we'll just put down a convert VDB, switch this to polygons. So now we have polygons for our bubbles. Now you might have noticed that our VDB operation isn't perfect. We still have a little bit of overlap between our bubbles and our liquid and our glass. So we're going to do the same trick we did for our liquid surface to kind of clip the bubbles by the glass object as well. So to do that, we can go over to where we surfaced our liquid, and we can just copy this operation we did. So we'll just copy all of this. Drag it down here. Then for our boolean, we'll plug in our bubbles, and this is still connected to our glass object. If you scroll out, you can see we're still working with our glass object as we were with our liquid surface. And we can preview our boolean. Then once again, this boolean, since we've copied it, it already has it set up so that we have that B inside A group. And then we're subdividing that B inside A group to fix the overall topology of the cut mesh. We've added normals because the Boolean operation messes up our normals on our geometry. We also have a fuse node to fuse together those created subdivisions with the original geometry. One thing to take into account, though, is that the overall topology of our bubbles is generally a lot denser than the topology of our liquid surface. So if we zoom in, you can see that it's actually crushing the geometry of some of our bubbles. So we actually need to reduce our snap distance a little bit. So I'm going to change this from 5 to 2. That way we're not crushing our geometry, but we're still making sure to close up those creases that we've created. And then lastly, I included this attribute transfer. And then lastly, I also copied this attribute transfer. And we want to make sure that we're transferring from our bubble points and not from our liquid points. So I'll just go ahead and connect this to our bubble points. And we're just grabbing the velocity value. These don't have vorticity. And we don't need the age on these points. So we'll just set that to velocity. So this way, if we go ahead and preview that, you can see that our bubble geometry is picking up the velocity from the points that they're originating from. Now, with all that set up, we can go ahead and cache out this geometry. Since this operation with the Boolean and the combining of VDBs is a little bit heavy, I definitely recommend caching out this geometry. So we'll just copy another file cache. And then rename this Rising Bubbles Render. And then once it's cached out, I'm just going to put down a null, just so we can grab it for rendering later. And I'll call it out rising bubbles. And then just change it to purple, because that's just something I like to do with nulls. And now we have our rising bubbles in our liquid. Now we can go ahead and tackle our final element, which is the stuck bubbles along the inside of the glass. Making these bubbles is the same general idea as the bubbles we just made, but without running a simulation. So I'm going to go back up to the glass where we sourced our bubble points. And I'm going to do the same thing we did with our blast before, so I'm just going to actually copy it. And I'm going to edit our current selection. So just click on this little arrow, go into wireframe mode so we can see what we're selecting. And I'm going to expand our selection a little bit further because the stuck bubbles, they don't have to just be on the bottom. They can be stuck along the sides of the glass as well. So I'm going to hit Shift-G a few times just to expand our selection. then we can go ahead and copy all these things we set up from before our simulation. So we can copy our scatter, peaking our liquid, our group, our delete, and our point peak. So we'll just copy that and plug our scatter into our new blast node. Just scoot everything over so that we still have a nice workspace. So now if we go over to our scatter, you can see we still have the points changing on each frame as well as reducing over time towards the end of our animation. We don't need that kind of behavior for our points that are going to be static bubbles, so I'm going to go ahead and break both of these connections by Control-Shift-Lick. So we can just leave the global seed at some random value, and then we can just set the force total count to a number we'd like. So I'm going to set it to say something like 150. So we have points scattered all along our glass. Then I'm going to just turn off the relax iterations. This way we do have some bubbles clumped together near each other and have a much less uniform look for our stuck bubbles. And then the same deal with our group that we've copied. The stuck bubbles will only show up where there's actively liquid inside the glass. That way we don't have bubbles randomly floating outside of the liquid or appearing outside of the liquid. Then we're deleting those points that aren't in our liquid, and we're peaking those points a little bit just so they're not directly intersecting with the glass. And then after that, we can just go ahead and copy all of this setup we did after our simulation. So I'll go ahead and grab all of these nodes, and just make a copy of them. And plug it into our new points. So you can see we have our randomized p-scale, we have our reduce amount node, which we might not need, so I'm just going to bypass that. VDB from particles, switch back to shaded mode so we can see them. So you can see we have our bubbles all along here. We have our VDB combine, so that we're clipped by the fluid itself, converting them into polygons, and then cutting them by the glass, subdividing and adding normals, and fusing those creases back together. And we can actually delete this attribute transfer because these bubbles don't actually have a velocity value on them, so we don't need this transfer. Now, one thing to take into account, if we go up to our VDB from particles, and we scrub through our timeline, you'll see that it looks like our p-scale is kind of jittering in the middle. And that's because our points, if we go up to our initial points and middle mouse, they don't have an ID attribute. And the attribute randomize is relying on that ID to base the p-scale value. So since they don't have ID, it's trying to use the point number. And that'd be fine if we had a consistent point number throughout the whole simulation, but towards the beginning and middle we don't. So it's randomizing that p-scale as the point number is changing. So to fix that, all we have to do is create an ID attribute for our points. So before we delete any points, so before our point number starts changing, we can just put down a wrangle. We can just set an expression that says @ID equals @pointNum. So now if we middle mouse, you can see we have an ID attribute. So now if we go back to our VDB from particles and we scrub through, you can see we're not getting that flickering p-scale. And then with all this other meshing set up, we're good to go for our stuck bubbles. So we can go ahead and grab that cache and out node that we used before, and just change the names for these bubbles. So I'll just call this stuck bubbles render. So stuck bubbles. And then I'll just change the null to match. So it'll be out stuck bubbles. And then with that cache, that's all of our elements for our champagne simulation. And if we zoom out, you can see we have a pretty decent sized network now inside of our sim geometry node. And again, as I said at the very beginning of our tutorial, I like having everything in this one node. That way, if I want to change something in our initial sim back here at the top with our main fluid simulation, perhaps I go through some of my iterations, or when I'm rendering, I notice that the foam, there's too much of it, there's too little of it, maybe it needs to be less dense, or something with the velocity needs to be changed. I can go ahead and change that right here. I can go ahead and run a new simulation, and it's already plugged into all these different elements we've created. Of course, it's not 100% procedural. If you do go back and you have little tweaks you want to make to your simulation, you'll just have to keep track of nodes like these where we've blasted specific particles, because you'll have to update that with whichever particles you want to get rid of. But other than that, it's pretty good setup to go ahead and recache all these different elements based on your main simulation. And now with everything set up, cached out, and ready to go, we're ready to start rendering. So in the next video, we'll set up some shaders for our different elements and set up some basic lighting and render out our animation.